Good afternoon, everyone. Thank you for joining today. We will be talking for about 45 minutes or so. We'll start with an introduction to climate science and policy. We will then explore how we go to calculating carbon footprint. And finally, we will touch on how to start on an emissions reductions journey. But let's start. Let's start really with a very simple point. We know that life on Earth would not be possible without greenhouse gases. So they do provide the natural barrier that create the livable environment we're all familiar with. So how is it that they have become such a problem, needing urgent action? Well, obviously, there's too many of them, too much of them, and much more than what the natural carbon cycle would have produced. Since the Industrial Revolution, fossil fuels extraction and their use in industry, transport, across all sectors of the economy have led to CO2 accumulation in the atmosphere. We now understand and can attribute global warming to human activities. The more greenhouse gases we will add to the atmosphere, the more dangerously our planet will change, with drastic impacts on weather patterns, ecosystems, biodiversity, agriculture, sea level rise, and the list goes on and on. Earth's climate has changed throughout history, and even in the last 400,000 years or so, you can see on the graph the CO2 concentrations have fluctuated. So these are measured in parts per million. The spikes and the reduction in CO2 concentrations on this graph refer to, so-called ice ages. But we can see that the present changes are really unprecedented. As you see on the tail of the graph, from the end of 19th century, the CO2 concentrations have been increasing at incredible speed. And even from the end of the 19th century, the scientists knew and could understand the heat trapping qualities of CO2. And already back then, they understood that increase in the concentrations of greenhouse gases would mean that the global warming would follow. But they could not expect that within a century, the concentrations would rise by 40%, something that they thought was only possible over thousands of years. And these are the temperatures. While there are direct measurements from the end of 19th century, scientists are able to use proxies and go back 2,000 years. And this graph highlights that the change we experience is really unprecedented. So we're currently at around 1.2 degrees. At the background, there is the illustration titled "The Climate Stripes," that shows that the observed hottest decade on record has happened in the last 10 years. With 2016 being the hottest and 2019 being the second hottest year on record. So we're at 1.2 degrees, and the heating increases every decade by about 0.2 degree or so. The dangerous human-induced interference in the climate system was first addressed in the international context in the 1990s. So it was in the 1992 when the United Nations Framework Convention on Climate Change was set up, and it had a nearly universal membership. The convention is the parent treaty of the Kyoto Protocol and the landmark Paris Agreement. So the parent agreement is a legally binding international treaty on climate change, and it was adopted in Paris at COP21. COP stands for Conference of the Parties. It was in December 2015, and it has as its goal to limit global warming to well below 2 degrees above pre-industrial level, with preference to sticking to 1.5 degrees target. The Paris Agreement provides a framework for financial, technical, and capacity building assistance to developing countries. So it kind of covers the principle of equal but differentiated responsibilities. So that the countries that benefited from development and industrial production support the developing countries. The Paris Agreement is also important not only in setting the 1.5 degrees target, but also in that they've asked the scientific body that studies climate change, titled Intergovernmental Panel on Climate Change, the IPCC, to produce the special report on 1.5 degrees to understand what it would mean and whether it's still achievable. And that special report has led to a recent wave of climate activism and really to creation of policies with the public pressure that came with climate activism. And we will talk a little bit about the policies in the UK context later. But first, I'd like to draw your attention to the latest IPCC report. So the scientific report, it's Working Group 3. So WG3 stands for Working Group 3. This is a big assessment report, of which there is the 6th assessment report, which happened one every 6 or 7 years. And this was published about 3 weeks ago. And it has the starkest warning yet, and perhaps maybe the final warning to the humanity, because the average annual greenhouse gas emissions are at the highest level in human history. So the last decade has added progressively 17% more to our total cumulative emissions. The global emissions, they state in the report, must peak and start to fall within 30 months to keep 1.5 degrees target alive. This will set us on the preferred pathway, which is illustrated on the picture in blue here. So the whole graph is global greenhouse gas emissions, and the kind of the fat lines are climate models that show the prospective pathways or trajectories as we go forward. And the red one, which is a trend, it's titled Trend from Implemented Policies, but it's essentially where we are currently with the present state of policy. And basically that line that gets us to 3.2 degrees by the end of the century is where we will end up if no more drastic action is taken now. Ideally, we should be somewhere on the blue or green pathway. So that's 1.5 degrees pathway and a green pathway, which is probably will limit the warming to 2 degrees, but there's a question of overshoot. The overshoot is a temporary, the climate system goes temporarily above the 2 degrees level, but then stabilizes at somewhere under 2 degrees. It's quite dangerous, perhaps because of uncertainty that comes with reaching an overshoot. The IPCC report had also had some relatively good news. There is an increased evidence of climate action. In some cases, the costs for renewables have fallen below those of fossil fuels, and there are options available now in every sector that can at least halve emissions by 2030. We will kind of revert back to go into a bit more details about the greenhouse gases themselves. Just to understand a bit more about their sources and what they are. And I guess this might be very familiar to most people who know about the science of climate change, but kind of the primary and overall they're a basket of 7. So there are 7 greenhouse gases that are controlled and that contribute to global warming. The main of those is carbon dioxide from energy system, transportation, industry. The next one is methane, produced by livestock in landfills. Also, it escapes in transportation and extraction of coal, oil, and gas. Nitrous oxide is the potent gas that's emitted in agriculture by agricultural soil management, use of fertilizers. And the F gases are really potent. They're man-made gases and mostly commonly encountered in old models of refrigerators or air conditioners, and also in medicine. A quick point here on the shorthand of carbon that we sometimes use for all of the greenhouse gas emissions. These are useful because all of these 7 are convertible into a CO2 equivalent, and global warming potential of carbon dioxide is counted as 1. And the other gases get a multiplier depending on the amount of heat they retain and their lifetime in the atmosphere. And this is, I mean, an interesting illustration of a ton of carbon there, but I guess, you know, it's an invisible, odorless gas. So what what would a figure like 1,000 kilograms of it mean? And you can see a little picture there. But in terms of comparison, and what we can talk about when we talk about a ton of carbon, you can compare emissions by an activity over time, per person, per product, etc. So in here, for example, UK is approximately at 15 tons per person currently, lower than in Australia, but much, much higher than in Malawi. And as you can see, the tons of carbon emitted per person change over time, of course, with the changes in the industrial system, but also in the way, we live our lives. And the next one is also even more interesting, because you can also find the figures for any kind of thing you want in terms of carbon content. So the first two things are like cement and steel that is used in construction. You can have a figure for a brick or a meter squared of a brick wall or timber frame, etc. So it means you can quantify the impact of all kinds of products that are being used in your work environment or in your everyday choices. So an interesting example here is a cappuccino versus a black coffee. So you can see that the tenfold difference there really tells us something about milk production and the fact that it's really quite carbon intensive. Bananas, on the contrary, seem to be quite good. Not a lot of carbon there. And an interesting point here, I guess, around the lifestyle choices that we can make, being informed by what's the carbon content of certain things or activities we do, is that if we just go back for a second, if our UK figure currently at about 15 tons per person, the World Wildlife Fund has a little footprint calculator for people, and it says the target for 2021 for the UK, so we're consistent with the trajectory to net zero, is 10.5 tons per person. So you can go into the calculator and have a look, but basically your home, your food consumption, and the type of travel you do will very much be used to calculate that individual carbon footprint. And for certain cases, the home would be 30–40% of your overall carbon footprint for an individual person. So addressing your kind of energy efficiency on the energy consumption in your home is quite crucial in terms of getting to a net zero pathway collectively as a nation. So just a quick recap again. We will recap the key temperatures. So if we treat the pre-industrial levels at 0, we are currently at 1.2 degrees or so. The Paris Agreement has a target of about 2 degrees maximum, but hopefully we'll get to a limit of 1.5 degrees. And you might have heard about Glasgow summit at the end of the year, where the whole world was on the UK to keep the 2 degrees target alive. And there were more and more pledges made during the talks, and the pledges come sometimes in form of nationally determined contributions, NDCs. So the think tank Climate Action Tracker has analysed all the NDCs by the end of Glasgow summit, and it looks like we were at 2.4 degrees target. So that is really, really insufficient. There are some good news on this, actually. There is a recent peer review publication, an analysis of pledges, which states that if all the pledges are implemented on time and in full, we're likely to be heading to 1.9 degrees. So it's a really good news, but I guess the point there, the policies to deliver this will have to be in place, and that is not the case at the moment. It's still higher than the desired 1.5 degrees target, and it is crucial that more progress is made by next year in Egypt, where the next climate conference will take place. And the reason it's crucial is because it's every fraction of degree matters in terms of the impact we will see in the world. And here again, something you might be familiar with, but the difference of half a degree globally would mean a significantly higher risk of extreme weather events, such as extreme heat with its implications to human health. Also storms and floods, which destroy the infrastructure, irreversible biodiversity loss. A substantial risk in some areas is water stress. So at 1.5 degree, it substantially reduces the risk and probability of extreme drought and risk associated with water availability. And final point, just on the sea level rise, is the difference is about 10 centimeters, which will come with with a half a degree extra. And that means for Arctic seas, it means the summer ice in Arctic would disappear every 10 years, as opposed to every 100 years at 1.5 degrees. For the UK, we know we're likely to see higher average temperature in summer, milder, wetter winters, and rising sea levels. More extreme weather events, heat waves, of course, that has massive implications to you as social housing providers because of the impact on the tenants, and of course, the pressures on the health system. Some studies show that 1.5 degrees for the UK would mean that London's climate would turn that of Barcelona. So kind of we're almost there, or we're on track to be there. But at 2 degrees, we would see extreme prolonged drought and really hot summers that they were quite shocking when they happened a few years ago, but we'll see them every other year. So at present, they are projected to happen once every 4 years. So to conclude here, to prevent further changes in the climate system, the global emissions must peak and reduce really quickly, and the polls coming in, really steeply to net zero. So by the middle of the century, by 2050, and that has to happen really steeply. So 30 months to reverse that trend and make the changes that are required to keep our planet livable and prevent really the worst. Just a final point is really that 2 degrees, or it's not an attractive target, it's really simply the best we can hope for, or the least worst outcome. So we're moving to the national policy context. So in response to Paris Agreement and the special report on 1.5 degrees, I think it really hit home a lot of the impacts that are expected. The Climate Change Act in the UK was strengthened. It was in place since 2008, but the target has changed to net zero by 2050. The reductions in the UK are summarised under a number of pathways, and as you've just highlighted, generating low carbon electricity is really important. So the energy system, grid supply is very important, and it's one of the primary targets of decarbonisation of the economy in the UK. The second is, of course, homes and businesses, addressing those by reducing demand and also changing the heat source to something that is less carbon intensive. In our cases, it's probably gas to electricity, or potentially oil. Greening transport. I think an important point here to make is that it's the active travel that really needs to be actively supported, because there would be inevitable emissions in the movements of goods, reducing emissions from waste, managing land more sustainably, and reducing emissions in the public sector, so that schools and hospitals that are reported separately. And in support of the target, the UK is reporting annually on its progress. And here is the latest data from a few months ago. It's the full year data for 2020, so the year of the pandemic. The headline figure here is we're 9.5% reduction from the previous year. Unfortunately, that is not really representative because of the impact of the pandemic, and unfortunately, the provisional statistics shows that this figure has been reversed, and the latest data for 2021 shows the emissions are up again on the previous year. But the important point for us here are homes. And let me see if I can see this is 16%. 16% of total carbon emissions in the UK are homes. Can see that residential emissions continue to rise, and of course that is a challenge. We know that the housing supply needs to grow. So how do we decouple the provision of new housing and the need for new housing from the increasing of emissions in housing? Just a quick note on the reduction, just for your information, the biggest reduction here, although the energy production, electricity production, has continued to decline for the 8th consecutive year. The biggest impact here is the decline in domestic aviation and shipping. So in the transport emissions here, we have internal flights and internal shipping, and that has basically stalled throughout the months of lockdown, hence the reduction in transport emissions, 19%. I mean, unfortunately, this were completely reversed by 2021. So I will go on to draw your attention to the National Housing Federation discussion paper. So as we pointed, around 16% or so are housing emissions, around 13% of those are space and water heating. And in line with UK emissions pathways, the homes emissions would need to be completely eliminated to be absolute zero by 2048. They also are expected to generate significant amounts of surplus renewable electricity through solar to support the other sectors of the economy. So the Climate Change Committee, which advises the government on how to reach net zero, they were really, really clear that that housing providers have a really significant role to play, and the road to net zero is focused on retrofitting all of the housing first, with vast majority of energy efficiency improvements being completed by 2035. And they also point to the need to adapt to the climate change that's already in the system. So really preparing homes for the impacts such as overheating and also dangerously the flood risk that might come with the changes in the UK. We will talk now about the scopes of emissions. You've just seen the reporting at national level, but doing it at the level of a project or an organization has to follow certain standards, and the first go-to standard is the greenhouse gas protocol, from which this diagram comes from. It divides all of the emissions in your boundary, in your scope, into 3 specific scopes. So scope 1 here in the middle is your company facilities and company vehicles, so all the on-site emissions. In scope 2, which is the grey arrow coming at the left, are the indirect emissions, which is purchased electricity, steam, heating or cooling. For most organizations, perhaps it would be purchased electricity. And then we have 2 big arrows in purple, upstream and downstream scope 3 emissions. There's all kinds of things included in them, and they are quite complex. But the reporting here has to be prioritized to activities that have a significant impact, and so where there are significant emissions and significant resource use, but also where you have the most significant levers of influence. So take purchase goods and services here in the upstream activities. So the helpful way to think about this would be, what are your biggest contracts? How are they delivered? Can you influence your key suppliers so that the products or services are delivered with less emissions? And perhaps we can think through some of the example of this in discussion. But in terms of downstream emissions, we have leased assets there. So for example, if you have a freeholder and you have a level of control over your assets, you can substantially impact their emissions and their environmental footprint by doing projects of improvement. So you might want to choose to report them in your direct scope 1 emissions or in your indirect scope 3 emissions, but this is really necessary in terms of those areas being the biggest areas where you can make a difference. And let's kind of discuss a bit more how this plays out in the way you report. So following greenhouse gas protocols, these are the main steps. So how do you start? First of all, you set the purpose of your reporting, or why do you do this in the first place? So will you report publicly and track progress over time? Will you plan your projects and investment based on the findings from the report? Would you be interested in identifying the hotspots or the priority sites or processes? Perhaps you'd be looking to enhance your reputation and use it for your stakeholder engagement. Once you address these questions, the next question will be to decide on the boundary, and in some way it will be informed by the purpose of your reporting. So here again, the question is around your kind of levels of the control, complexity of your organizational structure, but would you report on the emissions of leased assets as scope 1? A consideration here, well, does your tenant have sufficient control over the property or indeed the energy contracts? Would you report on your subsidiaries? Again, the answer to this will depend on the purposes you set. And number 3, thirdly, you would set the operational boundaries. So the greenhouse gas protocol defines scope 1 and scope 2 as mandatory. Scope 3 is optional. However, it is crucial that scope 3 emissions, the biggest emission sources, are addressed. So we are on track to achieve economy-wide reductions. You know, it's all the sectors of the economy that have to be decarbonized. So in conducting something called materiality assessment, and I'll talk to this on the next slide, you'll be able to identify what are the key impacts in your scope 3 and what you have to report and reduce. Fourthly is the question of base year. Will you use the last year, or will you use the year for which you have the complete set of data? Will it be a representative year? Is it useful to track progress against? Fifthly, you calculate the emissions. So you find the activity data, some underlying, perhaps activity data, miles traveled or kilowatt hour of energy. You use the appropriate emissions factors, of which there are wealth of them, and there's loads of sources of them, but greenhouse gas protocol would be your point to start, and then refer to, for example, BASE, so nationally published emissions factors, and you perform calculations. And final point, manage inventory quality. Sounds really onerous, but essentially this means a process of how you calculate your emissions, with which assumptions, and the kind of the methodology that you followed is well documented so that it's repeatable next year according to the same methodology. It's quite important the procedures are clearly set out and are followed precisely because you might need to recalculate the baseline, or you might need to revise some of the emissions factors. So all of this would have to be transparently documented and be consistent over the years. You know, it does sound like a complex process, but worry not, there are standards there. So greenhouse gas protocol is one, ISO 14000 group of standards that are there to help you and guide you through the process. And I've mentioned materiality assessment. So it's kind of the question about the boundaries and the scope 3 emissions. And, you know, because they're so wide, how would you know which of the impacts are the most material, are the most significant for your organization? And there is a method called materiality assessment, so which involves interviewing stakeholders and researching details of the risks and the trends in the relevant markets for certain supplies or for certain activities. But in the shorthand, it could be presented as a checklist, which an example you can see on the screen. So you would go and systematically answer these questions for all of the categories of your scope 3 emissions. So leased assets, some of you were saying they are the biggest contributor to your emissions, and I tend to agree with this. This is probably likely the case. So would they be more than 40% of your total emissions? And the answer is yes. Would there be a clear opportunity for energy efficiency? Again, probably so, because you do have the control over the building itself. Potential future resource or energy risk? Yes, one would imagine that energy security concerns are only growing with the recent global events. So probably the answer yes on that point as well. And finally, opportunity to engage with your suppliers and customers. And this is pretty clearly that it would be yes, for the tenants with whom you engage on various topics all the time. So perhaps it's another opportunity to work with them in collaboration to reduce the emissions from housing stock. And let's look again back to to the question of buildings. So we have operational emissions, that is scope 1 and 2, so on-site emissions plus purchased electricity, that would be the day-to-day emissions of running of the property. So the calculations there is pretty straightforward in terms of your carbon emissions would be the kilowatt hour energy times the relevant emissions factor. So obviously different for different types of fuels. You might have a data, for example, a separating or the property, or if it's for individual household, you might have an energy bill, or perhaps if you own some communal heating systems for which you also have the energy bills to use. Operational emissions are addressed through various ways. So in the new builds, you would have the building regulations, the planning policy requirements. Also for the non-domestic buildings, there are, and actually perhaps for domestic as well, there are sustainability rating schemes there. However, emissions of housing stock in operation cover only a part of the whole picture. There are also capital works, maintenance, demolition, and final disposal. Or if you look at the beginning, the process of construction of the new building itself. So the total life cycle footprint of a building includes both of those things: the operational emissions, over the years the building will be there, plus the embodied emissions that are really happen from in the very beginning, during the maintenance, or at the very end life of the building. And just to go a little bit more into the detail of this, so on the pie chart on the left, there's a breakdown of a whole life carbon of a medium residential building built now with current building regulation, in compliance with current building regulation. So the yellow part of the pie is the in-use operational emissions. So your heating, hot water, ventilation, lighting. It seems, well, it is by far the highest chunk of emissions, something around 75% perhaps. On the right, you will see a slightly smaller pie, which is a whole life carbon cycle of the same building, the same size building, but constructed to ultra low carbon specification. And over its lifetime, so it has improved fabric, it's a heat pump as an energy source. And over the whole lifetime, you can see that operation emissions become a quarter of the whole pie. So the impact of construction and demolition at the end becomes quite significant. So as we progressively achieve high standards in the new buildings, the industry itself has to change and move towards focus on reuse of materials and implementation of principles of circular economy. And just to reiterate, the homes built today will be here for hundreds of years to come. And we also know that there should be no emissions from homes by mid-century, the latest. So it's really important that we build now really well to avoid the need of future retrofit and avoid future costs and disruption, in the coming 20 or 30 years. But also this pie chart show that the focus on embodied carbon should really start to happen now, so that the construction industry also changes. We're moving kind of to the final section of our discussion today. And I just thought it's important to reiterate some of the terms that have been used are quite widely, but they mean slightly different things. So the definition of net zero carbon here you see, which means that the carbon dioxide released through activity is reduced as much as possible at source first, and then balanced by an equivalent amount through offsetting, which is quite different from carbon neutral. So carbon neutral means that CO2 emissions are cancelled by equivalent amount of offsetting. So there is no focus there on reduction of emissions and at source. So I guess a consistent way of reducing emissions would be to go towards net zero carbon rather than carbon neutrality. And on the right is a reminder of a diagram of definition of what net zero operational carbon building is currently, and it has the 5 segments there. And I'll start with yellow. So it has a low energy use, so the total energy intensity is really very low, so you reduce emissions at source. Perhaps you need a relevant target to address that. On the right side, low carbon supply means that annual that there is no fossil fuel use on site really. So all of the heat and hot water is generated by renewable sources, and renewable sources would obviously mean that you would have renewables installed on sites. On the green section, you have measurement verification, so you have to know the energy consumption and monitor and report on this over 5 years, including what the energy consumption has been, but also what the on-site generation has been. The zero carbon balance on the right corner, it means that if the balance between on-site generation and use has not been achieved, you would invest in offsetting. And finally, the embodied carbon. For net zero carbon buildings, we're looking to assess, reduce, and also verify post-construction the embodied carbon of the site. And you know, here is an example from Hyde Homes, a housing association in London and South East, and it shows how the net zero definition has been made use of in the climate strategy. You might have heard of waste minimization hierarchy: reduce, reuse, repair, recycle. So that's the same principle that is used for carbon and energy management. So the first step is avoiding adding emissions, then reducing them at source. Finally, perhaps replacing the heat source from gas to electricity or something that is less carbon intensive, and finally offsetting those emissions that are unavoidable. And this is really, it looks like a good practice in terms of using the hierarchy. And in terms of action planning, you know, once you understand your emissions and you define the hierarchy that you have to follow, it's important that policies and actions are formulated, taking into account the levers of influence you have over the sources of those emissions. So at the core, you would have emissions that you can directly address, perhaps that you can showcase as something that achieves really great results and you have complete control over it. So a change in business practices and investment in energy efficiency of your assets. Then you have the next level of influence, those emissions that can be controlled. For example, you create a policy, for example, a policy for new builds. You know, you set the energy targets, that's kind of the way you want your future buildings to be constructed, and it will inform all your future decisions. And on the outer circles, you have emissions that you could influence. So, for example, would be an engagement with your supply chain or engagement with your residents, kind of with a view of looking to change their behavior. There is a bit more uncertainty about the level of control you have and the level of outcomes, but it's important that you choose the right measures depending on where you are in this kind of range of levels of influence. And when writing your action plan, it's important that you identify the metrics and the targets. So you create a SMART objective, which is quite specific and measurable, and of course time bound. And it's quite interesting that sometimes finding the relevant metric is quite a difficult task. because you should be able to monitor the measure and monitor it before and after the project. So I think that's a crucial point to make here. And we're wrapping up. We're almost out of time. Just a reminder, really, that when we start working on a significant challenge, and we all know that a huge change that has to happen across all spheres of life, stemming from climate emergency, we must also remember that this change brings huge benefits. In the process, we'll create jobs, improve health outcomes, for example, through air quality or changes by active travel. We also have an opportunity to reduce inequality. The homes are the biggest contributors to the UK emissions, and all of the existing homes will have to be upgraded. So net zero is also an opportunity to build a healthier and more prosperous communities. And the Sustainable Development Goals here, which you might have heard of, but they're kind of a reminder that when we're addressing climate emergency, we're also making sure that nobody is left behind. It is important to stress that working together with the communities, customers and suppliers, we're building a more sustainable, safer, a more prosperous planet for all of the humanity. And I think these are my final remarks for today. So first of all, understand your key impacts. We've talked about footprinting and materiality assessment. That's quite crucial. You need really good data. So invest in data collection, manage your data well. Of course, manage your energy supplies and engage with your contractors, be it energy or other. Set good targets, find the right metrics, learn from what's going well and what's not really going well. So adjust your actions if needs be. And finally, share success with others. Really learn from each other as well. Thank you so much for your time today.